So welcome friends, this equation of uniform restless motions. Equations we have to prove here. You see here, this is one car which is moving on the straight line path like that. We have the uniform acceleration motion of the car. Suppose the initial position of the car is time t is equal to 0, start the motions starting from one place to the final position to the other place. At that time t is equal to t. So there is a two position, initial and final position, for a constant or the uniform motions of the car for one place to the other place. So let us see, we can get the same idea with the help of this model. We can get idea with the help of this in a form of calculation by the on the road the car is moving. Let us see, we can draw the figure for that in the x dimension, you know very well. Suppose the initial position of the car, that is the position initial, that is in the form of the car in this position, that is the time t is equal to 0. Now let us see, this car have the velocity, initial velocity v is nothing but v0. Now this car start the uniform accelerative motions and reach to the final position of the given this place. So at that time, suppose time t is equal to t. So the velocity, that is final velocity, v is equal to v is there. So car is reached to here. This is the final velocity of the car. Now this uniform acceleration motion which we have imagined, that calculated in the form of graphical method. This is the motion on the x dimension. Suppose same thing we have to calculate in the form of graph. Then how we calculate? This is suppose x dimension. Then we can say this is your y dimensions. We just now clear that initial position of the car, t is equal to 0, that velocity v is equal to 0. So in the graph we can put here this position on the graphical method. Suppose initial velocity we are putting here, that is v0. The car is a constant accelerative motion reached to here. At that time, the final position of the velocity, this final position of the velocity, suppose graph reached to the here. At that time, the final position of the velocity, that is the velocity v for a given this figure. So what we can do here, this is the graph just extend more. So final velocity, suppose v is here, and the position of this is the final positions, initial position and final position, which we can do in the form of experiment here. This is in the form of graphical experiment transfer in the graphical method. So let us see now what is happen. This is graphical method, we can get the initial observations and this is the final observations. Let us see here, origin is a with respect to the dimension x and y, O is a origin. Suppose the point A is there, this one, and that point A you can transfer here in the form of point A, initial point A, final velocity, suppose a point B, and with respect to the x dimension we can just draw the graph to find the area like that. Then we can get one triangle here, and that point we are getting, that is A, B, C supposed, and reach to the x dimension, suppose a point D. Remember friends, when the car is there in the form of initial position v is equal to v0, on the graph on the y dimension initial velocity is v0. We can get here the slope of this. This is the slope for a given this triangle. So the slope of the graph, which we can calculate in the form of given this triangle. So let us see first equation for a calculation from the graph. We can say here about from the figure, the acceleration A is equal to slope of the graph in the form of slope of the line AB, slope of line AB. You can see in the figure line AB, which gives the nothing but difference of this. Let us see, we can see in the graph difference of this V minus V0. So slope you know very well, this region, that is a BC upon AC. So what is the BC? That is a V minus a V0. And what is the AC? Total time T minus T0. So total time T. That is again nothing but, that is the time T with respect to the given value, initial and final time minus initial time. This is the method calculated by graph. Simplify these equations. So what we are getting, A is equal to V minus V0 upon T. Again simplify, more simplification is there. That is AT is equal to again V minus V0. We have to give the capital of V here. So more simplification, transfer here, we can say here V is equal to V0 plus AT. You know very well friends, this is our first equation of the uniform accelerative motions for a given one equation, that is equation number 1. Remember that V0 is initial velocity of this car. Again V, which we are getting here, that is the final velocity of this car. And the equation V is equal to V0 plus AT. Now this thing we can transfer in the form of displacement. How the car is going to be displaced with respect to the initial to the final position with the graphical method. So to calculate that graphical method, we can calculate here again. The triangle is a given. Basically total area covered from the origin O, A, B, C, D. This much total area covered in the form of displacement of the car. So the displacement of the car to cover by this much area, let us see, we can calculate again more simplifications for the calculation here. So from the figure you can observe here the triangle, that is the triangle about the ABC. At the same time the rectangle, that is the OACD. So second equation, that displacement X is equal to the rectangle, area of the rectangle OACD. OACD, that is the rectangle of this area. Similarly is a triangle ACB, that is triangle ACB. So how we can calculate? You know very well. This is the V0 is there and time T. So we can say V0T plus triangle, area of the triangle you know very well. That is 1/2. That is the base and width is there. So what is happen is a V minus a V0 into T. Because total time T minus T0, total T is there. Now give more simplification of that. But you know very well V minus V0 from the equation 1 we can get the idea here, that is the nothing but X is equal to V0T plus 1/2, that is A into T again. Why? Because from equation 1 we can get the idea V minus V0 is nothing but AT. From equation 1 we have calculate. So more simplify here, X is equal to V0T plus 1/2 AT square. So these are the second equations. In this second equations, we can say here about the x is a displacement and a is acceleration, that is the uniform accelerations. So these are the second equation of the uniform acceleration motion is there. Similarly, about the third equation we can prove with the help of that the same equations. So we never give more writing here. Let us see. Simplification, this much you know very well. Again applied here, that is the x is equal to v0t, more simplification, plus 1/2, open the bracket, is a v, t is there, minus 1/2 v0t. Remember, two same ideologies there. Therefore, x is equal to v0t minus 1/2 v0t. So it's a 1/2. Again, v0t plus 1/2 vt is there. Simplify more this equation. So what we are getting again is a v plus v0 upon 2 into time t is a common. From equation 1 we know that about the v minus v0 upon a is nothing but time t, that we already calculate from equation 1. With this value we can put in this equation. So what we are getting here, that is x is equal to v plus v0 upon 2, and time t is nothing but again v minus v0 upon a. So simplify these equations. X is equal to a plus b, a minus b, so all has to square. So v square minus v0 square upon 2a. So these are the simplification. Again give more simplification of that. Therefore x is equal to 2a is there, so 2a is here. So twice ax, let us see, okay, twice ax is equal to v square minus v0 square. So remember friends, this is our third equations, that is the equation x, y and z. Third equation of the uniform acceleration motions, where you know a is accelerations of the uniform accelerations. These three equations mainly used in the fundamental equations for the 11th and 12th science friends. Now let us see same thing if we calculate about the gravitational field, how with this equation compare. We already calculated friends three equations of this. One, v is equal to v0 plus at. Second equation about the x is equal to v0t plus 1/2 at square. At the same time, third equation is twice ax is equal to v square minus v0 square. Now these equations I will try to compare directly with respect to the free falling body. How the body is going to be freely from the given these positions. So any body is there which is a free falling body. Suppose this is one body here which is a free falling body with respect to the gravitational field. So with respect to the gravitational field, this we can calculate here of a given one example of the ball. Let us see. See friend, the ball is moving downward direction. Why the ball is moving downward directions? Because gravitational force is applied to the ball. So these three equations we can transfer in the form of downward direction of the g plus g. At the same time the ball is moving upward directions, that is a minus g. So these three equations I will write again in the form of free falling body. One equation you know, v is equal to v0 plus at. This is our equations. You can transfer this equation for a plus g. This equation you can transfer for a plus g, and that is the for a plus g downward directions. then this equation we can transfer v is equal to v0 plus gt. At the same time vertically upward direction, then this sign is again a change, and we can say v is equal to v0 minus gt. Remember at the g upward direction, where plus g is downward directions. So this is very simple for the first equation. Second equation, that is the x is equal to 0 in the form of x is equal to v0t plus 1 half at square. Let us see, simplifying the two way. 1 plus g in the form of downward directions, minus g in upward direction, vertically upward. So how we can transfer? That equation we can transfer in the form of, again, that is x is equal to v0t plus 1 half gt. At the same time, x is equal to v0t minus 1 half gt. Square is there, you know very well. Similarly, for the third equation, we can calculate about the same thing for the third times, for the plus g and minus g. So twice ax is equal to, you know very well that equations, twice x equal to v square minus v0 square. Transfer this in the form of plus g. So twice gx is equal to v square minus v0 square. For a given transfer of the minus g, minus 2gx is equal to v square minus v0 square. So remember friends, these three equations transfer in the form of plus g, again three equations. Transfer of the minus 3, again 3 equations. So if you get 3 equations, then you are again get total 6 equations plus and minus g. So total 9 equations, which is useful in the numericals for the physics. So we can calculate the time of the numericals. Okay, thanks.